Hello everyone, in this video I'm going to discuss the topic differentiation. So find a value of k so that the function fx, which is a piecewise function, is continuous. So before we further our discussion, let us illustrate the situation or the function in a number line. So now we're going to discuss the function. So where we have a point which is equals to 2. So kindly refer to the function x is less than equals to 2, meaning that for the left hand side, the function will be kx squared. If x is greater than 2, so the function would be 2x plus k. So in the question, they already mentioned the function is continuous. So by using the definition of the continuity, for the second condition, they state that the limit exists when x approaching 2, either from the left or from the right. So meaning that limits when x approaching 2 from the left, the function will be kx squared, which is equals to limits when x approaching 2 from the right for the function 2x plus k. So now by substituting the value, so we will have 4k equals to 4 plus k. Rearrange the situation and we will have 3k equals to 4, where k is equals to 4 over 3. So now we already have the function, so which is 4x squared over 3 when x is less than equals to 2. And for x which is greater than 2, the function would be 2x plus 4 over 3. Next, we are going to further our discussion. Hence, by using the definition of f prime a equals to limit when x approaching a for the function fx minus fa over x minus a. Determine whether the f prime 2 exists or not. So now we are going to use the definition to determine whether the function f prime 2 exists or not. So now we begin with the left hand side. Limits when x approaching 2 from the left. Okay, 2 from the left. For the function, we will have fx, which is equals to the left. So we are going to substitute 4x squared over 3 minus fa. In here, a is equals to 2. So meaning that we are going to substitute the value 2 into the function on the left. So where we will have 2 to the power of 2, which is equals to 4. So 4 multiplied with 4, we will have 16 over 3. So the function fa will be equals to 16 over 3 over x minus 2. So rearrange or simplify the situation. We will have limits when x approaching 2 from the left. We have 4x squared minus 16 over 3 bracket x minus 2. So if we substitute the value, we will obtain 0 for the numerator and also 0 for the denominator, where we call it as indeterminate form. So there are several strategies that we can use to solve this kind of situation. First, multiply with the conjugate. Second will be factorizing the situation. So if we're factorizing the situation, and we will have limits when x approaching 2 from the left, 4 bracket, we will have x squared minus 4 over 3x minus 2. Still, we need to factorize the x squared minus 4. And we will have limits when x approaching 2 from the left, 4 bracket x minus 2. x plus 2 over 3x minus 2. So finally, limits when x approaching 2 from the left, we will have 4 bracket x plus 2 over 3. By substituting the value 2 into x, and we will have 16 over 3, meaning that when x approaching 2 from the left, the value of y will be approaching 16 over 3. Next, we are going to discuss the left hand side to the right hand side. So limits when x approaching 2 from the right, the function would be 2x plus 4 over 3 minus, for FA, it will still be the same, which is 16 over 3 over x minus 2. Simplify the situation. 4 over 3 minus 16 over 3. We will have negative 12 over 3. So which will be limits when x approaching 2 from the right, we will have 2x minus 4 over x minus 2. So if we substitute the value, we will obtain 0 over 0, which will be indeterminate form. So I repeat the situation, meaning that I'm going to factorize the situation. So limits when x approaching 2 from the right, I'm going to factor out the 2, so we will have x minus 2 over x minus 2. Finally, limits when x approaching 2 from the right, after we simplify, we will have 2 as a function. And finally, when x approaching 2 from the right, the value of y will be approaching 2. So, in conclusion, limits when x approaching 2 from the left for the function fx minus f2 over x minus 2. For the right hand side, limits when x approaching 2 from the right for the function fx minus f2 over x minus 2. Does it equal? So for the left, we will have 16 over 3. For the right, we will have 2. So in conclusion, the limit does not exist. So meaning that f2 is not differentiable. Or we can say f prime 2 does not exist. So here we are, and thanks for watching.